everyone. My name is Chris Develder. I'm a professor here in Ghent at Ghent University. And I'll be chairing the session on NLP. We have two speakers for you today. The first is Professor Veronique Hoste, also affiliated with Ghent University. She's heading the LT3 research group, so that's language and translation technology. And she's mainly been focusing on emotion and sentiment analysis, and that's also the topic of her talk today. So I'll give the floor to Veronique.
Okay, merci. Just have a look. Okay, so good morning. So the topic of my the topic of my talk today will be towards more empathic conversational agents. So the focus will be on the two words. So there are no empathic conversational agents yet. So I also want to don't be too eager on finding some solutions for empathic conversational agents at the moment, so I won't give you any. But I will show what we have done in order to reach this goal of empathic conversational agents, and I think we already go a long way into this direction of empathy in chatbots, or also maybe in speaking and hearing conversational agents. So the work I will be presenting is part of the Flanders AI program at one hand side, and at the other hand side is part of an FWO project we have currently. And this general goal of emotions in human agent conversations is in fact very old. So here you already have a statement of Picard in 1997, and in AI terms 1997 is very, very old. And he states that if we want computers to be genuinely intelligent, to adapt to us, to interact with us, then they will need the ability to recognize and express emotions, to have emotions, and to have what has come to be called emotional intelligence. So in fact, if we talk about artificial intelligence, no artificial intelligence without really understanding language. And language is not only understanding the factuality about language, it's also understanding the empathy involved in expressing language. Okay. So when we think about emotions in human-agent conversations, I think the two statements I put there are in fact a bit kicking in open doors. So research on human interactions has shown that empathic engagement has a positive effect on the outcome of several communication tasks, such as, for example, persuading voters, patient satisfaction and compliance, and we also see this in a CRM context. So in customer relationship management, we see that if you react correctly to a customer complaint, and if you react empathically, well, it reduces churn and increases customer satisfaction. We all know this. We as human beings often know how to do this, being empathically in our conversation with customers, but how do we learn chatbots, or how do we learn conversational agents to also understand emotion and act upon it? So when we look at emotions in human-agent conversations, quite some work has already been done in the past, but focus has mainly been on, from the domain of affective computing and also in social robotics. So for example, here also in our university. And until now, the focus has mainly been on visual and paralinguistic characteristics. So on visual characteristics, I'll talk about Ekman in some minutes, and also paralinguistics, so the signals you often find in speech, for example, pitch. Yeah, but at the moment there's very little being done on trying to understand emotions in text. And this is in fact what we need when we are, for example, in a chatbot setting. So there we need fine-grained emotion detection in text. And when we try to model conversations in chatbot context, well, people often, for example, in a CRM context, start off angry, and hopefully, depending on the responses of the chatbot or of the human operator, in the end, they turn well, happy might be a bit too much, but they are satisfied with the solution brought forward. So you should be able to model dynamic emotion trajectories, so how emotions evolve in time, and what response strategies work well, what response strategies are maybe counterproductive, and in the end, you just want to have a happy customer. So the focus of my talk today will not so much be on the left side of the slide. So I won't talk about the ASR part, about the TTS part. I will mainly focus on the natural language understanding part, and maybe also briefly talk about the natural language generation part, because one goal is not only to understand emotions in text. The second, at a given point, you should also be able to convert this knowledge into an empathic answer to your customer. Okay, I think by everybody in this room knows what sentiment analysis is. It's already a fairly old application being used a lot in business contexts nowadays. I think most companies in Belgium, but also public governments use sentiment analysis to know what their stakeholders think of them. And often it boils down to simple polarity labels, so positive, negative, and neutral. So in fact, it's mood detection. So can we determine the mood of a certain person towards a certain company, towards a certain product? So what we have been doing in the team for the last years is that we try to surpass this more coarse-grained sentiment level to a more fine-grained emotion analysis. And there's quite some work to do, because when you look at sentiment detection, so polarity classification, it's only scratching the surface of what is really said and of what is really interesting from a stakeholder management point of view. So what is important, also implicit sentiment. So most of the current tools on the market don't model any implicit sentiment. They model explicit sentiment. So they model explicit realizations of awesome, great, so mostly explicit sentiment in social media. So what we have been doing in the last years is also focusing on implicit sentiment, for example, in the framework of economic news detection. So you have economic articles being written. I think that you all know by now that, not being an expert in economics, that the stock markets don't behave rationally. So they behave on the basis of what is being written in news often. And so the reaction there's a reaction to positive news, there's a reaction to negative news. And this trying to, or being able to model this sentiment, these events, and the sentiment attached to these events, and being able to model this would be very interesting, not only for portfolio management, for example, but also, for example, in algorithmic trading systems, which currently mostly work on the basis of, financial data at the moment. So what you see there, some months ago, 2 months ago, a research, a PhD was defended on this topic on economic news event detection and sentiment analysis. And you see on the bottom of the slide, you can see how we annotate these data. So it also led to a gigantic database of annotated data with not only implicit sentiment, sentiment, but also with events. And why are these annotations important? Sophie already talked about it. Data is crucial when you want to develop good machine learning algorithms. And in our team, we develop a lot of data sets. Yeah, because we know that if we don't have good data at our hands, we will never be able to develop sensible systems. Okay, another thing which is important when we think about sentiment is irony. You know that when we express sentiment, we often do this in a very creative way, and often we use irony to express that we mostly are not happy. And this is also something we've worked on for quite a while now, and which is important when you want this empathy in your chatbot. And what is important or interesting there is that it's not only about sentiment analysis, it's also about common sense knowledge modeling, yeah? And it's not about common sense knowledge in building common sense knowledge bases with factual knowledge. It's in fact common sense knowledge, it's connotational common sense knowledge. Things happen in life, and some things we like and other things we don't like. But how do we try to model this? And you really have to have this dynamic modeling of this common sense in order to be able to model any irony. Because as you see it here in this slide, you find irony is realized through a clash between sentiment and something which people usually don't like. But how do we know what people usually don't like? Yeah. So this is also one of the research lines in our team. And if time permits, I will also talk how we try to tackle this. Another important fact is if we want to know, if we want to build empathic chatbots, we don't only want to know whether they are positive, negative, or neutral, or whether the customer is positive, negative, or neutral. We want to know what this customer is positive, negative, or neutral about. And mostly we are interested in knowing what he is negative about. So in fact, we need aspect-based sentiment analysis. And this is a slide referring to a current TETRA project we have with a couple of companies, of which I see some in the audience. And this is a TETRA project on aspect-based sentiment analysis and emotion detection. And what is the goal there? The goal is, first of all, to detect what people are talking about, and to try to categorize it, and also to link emotions and sentiment to it. And also there, this is also very domain dependent. The idea is also to, when the system makes errors, to have some kind of feedback loop in order for the machine learning system just to retrain on a specific domain. And then the last part I would like to talk about is how can we have emotional systems? So emotion is not about positive, negative, or neutral. It's about finding out whether people are really angry, whether they are annoyed, whether they just want, whether they are disgusted, and so on and so forth. Because these are the people you want to directly respond to, for example, when we think about CRM context, or when we think about a chatbot in, for example, we worked together some years ago with a suicide prevention center, in which we developed a system for the detection of suicidal thoughts on social media. Well, there the emotions are completely different. So there you want to feel, you want to be able to directly find these suicidal emotions, these depressive emotions. Okay, so this again is then for example, here I also again refer to our project on emotion analysis and our Vlaio project. So all these emotions are again fed into a system that is mainly using machine learning to do the processing of new unseen data. Yeah. I didn't talk about methodology. I think in the first talk this morning there was already a very good overview of feature-based machine learning approaches, neural network machine learning approaches. We use them all. So we both use feature-based machine learning approaches if we don't have enough data at our hands. We use BERT-based, transformer-based approaches, which we fine-tune on our data sets if possible. And we try to see what works best in which specific setting, which is in fact completely normal in any scientific context, I think. Okay, so I think I mainly explained this to you, but a brief note on data. One of the huge problems we have, for example, if we want to build empathic chatbots, is that we don't have data. It's easy to build systems if we have data, but we just don't have any. We have data for emotions, which we mainly build ourselves. We have data for all the other stuff I talked about, but this is what we are currently working on. So at the moment, we are just making our hands very dirty by hiring a large bunch of job students to do annotation work for us. Yeah, well, my hands are not that dirty. And okay, so, and what are we doing at the level of data construction? So we construct personality data. How do we do this? Also in citizen science projects. So we try to define citizen science projects, such as, for example, the Burgerpraat project, in which we try to collect data from 1,000 Flemish citizens, personality data, but also spoken data from them, in which they talk subjectively on all topics they like. So we want them to express emotions in text. What are we also doing? Crawling a lot of data, try to find data, all data we can lay our hands on, and then we have our battery of job students that do the annotation work. And what we also do now in the context of chatbots is Wizard of Oz experiments. So this has to pass in an ethical committee, because in fact we fool our participants. The problem in human resource conversations is that when the customer starts being very angry, he's taken offline. Yeah. Then we don't have interesting data anymore. So what we now did is set up experiments, Wizard of Oz experiments, where we had different scenarios and where we try to evoke different emotions in the participants. The participants think that they are talking to a chatbot, but in fact one of our job students is playing the chatbot and is trying to make this person behind the computer angry. And the strange thing is that I think 98% of the participants didn't realize that they were talking to a human being, while at a certain point this chatbot was really rude. But it gave us fantastic data, and now we are starting to work on this data to build our empathic chatbot. Okay, so I hope I explained to you what we've done on in the domain of emotion detection and how far we got. I think we got quite far on the text level, but now we have to integrate it in a conversational setting, and we are currently working on data collection to mimic this conversation setting too. Thank you very much.
Okay. Yeah, we can maybe take just one question, real quick. Okay, so just for the audience, the question is about how do you distinguish between cultural differences and how do you accommodate that, basically?
Yeah. I think this is a very interesting question, and we are currently also looking into this question. At the moment, we mainly focused on emotions which are, well, in cultures. So, for example, in English, in Dutch, in German, in French. So, in fact, we can consider them culturally very close together. But at the moment, we are also doing experiments on the portability of our systems to, for example, do emotion detection in Hindi or do emotion detection in Chinese, and to see whether we are able to find, and we combine this with language detection, whether we are able to find language agnostic or culturally independent features to build, in fact, a culturally independent emotion detection system. Yeah, that's work we are currently working on.
Okay. Thank you for the interesting question. In the interest of time, I propose that we leave further questions until the end of the session, if time's left. So let's now move on to the second speaker. So that's Jens Nevens. He's a PhD student at VUB, so Brussels University. And he works mostly on how to learn or to teach intelligent agents, or how to see how they can represent and learn linguistic structures, and then use those learned structures in advanced perception, reasoning, and also communication tasks, so also in the context of chatbots. So I'll give the floor to Jens and give him some time to connect his laptop, because he also intends to give a demo, actually.
Thank you, Chris, for the introduction. Hello, everyone. So I'm Jens. I will talk today about hybrid procedural semantics for conversational agents. But before I explain to you what hybrid procedural semantics are, I have to give credit where credit is due. This is not my work that I will present today, but it's the work by Lara Verheijen, who is doing her PhD on this topic, supervised by Dr. Paul van Eecke and Dr. Katrien Bults, who could not be here today. So I will try my best and explain their work as good as possible. This work, Lara's PhD, is situated within the AI Flanders Research Program within Grant Challenge 4, Human-like AI, in Work Package 2 about conversational agents. So I would like to start this presentation by trying to formulate for us what is the main challenge in conversational agents. And for us, this is the integration of new observations that come in, for example, text in a chatbot or images, and integrating this with previously acquired knowledge. So knowledge that is built up over the course of the conversation, but this can also be other knowledge, like domain knowledge that it's necessary for your particular application, or ontological knowledge, common sense knowledge, and so on. Closely related to this, and I put this between parentheses, is the integration of unstructured data and structured data. So these texts and these images, this is completely unstructured, and we want to analyze this, extract all the meaningful information that we need, structure this, and store this. This can be in any way that you want. This can be a table, this can be a knowledge graph, an ontology, a database, and so on. So when is a conversational agent considered to be good or successful? We think you have a good conversational agent when it is able to combine both of these sources of information, so new observation and previous knowledge, because it is only then that it will be able to have a meaningful and coherent conversation with end users. So this is a big challenge, and our first step in tackling this challenge was a case study on the task of visual dialogue. So this task is illustrated by the figure that you see here. And the task is to answer a series of questions about this image. And to successfully do this, you need to integrate information from the question, the image, and the dialogue history. So we can see this when looking at the example at the top of the slide. The first question about this image is, are there any triangles? Well, to answer this question, you only need information that's available in the image. But then the second question, how many? Well, here you need to refer back to the dialogue history. How many what? You need to go back to the previous question, and there you will find they were talking about triangles. So then you combine this information with the information that's in the image to find the answer that there is only one triangle. There are other problems to solve as well, like solving coreferences. This is illustrated in the third question. Is there an object to its left? Well, what does it refer to? Again, we need to access the dialogue history, and we need to access the image and combine this information in order to provide an answer. And we applied our methodology on two benchmark datasets, the MNIST dialogue dataset and the Clever dialogue dataset. So what is our approach that we used on these datasets? It consists of 3 parts. First, we have computational construction grammar. So this is our language component of the system. Then we have hybrid procedural semantics. And the third component is a conversation memory. So I will explain these 3 components and how they fit together. And in the end, I will give a live demonstration of our system applied to this Clever dialogue dataset. So the first component, computational construction grammar, this is the language component of our approach. And specifically, we use fluid construction grammar, or FCG. This is software that we develop in the AI lab in Brussels. And what can you do with FCG? You can map a linguistic utterance onto a representation of its meaning. This we call comprehension. And you can also do the inverse process, so mapping a meaning onto a linguistic utterance, and this is formulation. So it's a bidirectional system. Why? Because we also use it in research on the emergence and evolution of language, and there we want our agents to have bidirectional language processing capabilities, well, like we do. In visual dialogue, only the comprehension aspect is important. And what's also important is that FCG offers us a transparent and human interpretable linguistic analysis. So this is a search process that's going on, and every step of this process you can investigate why FCG found that particular linguistic analysis of the question. The second component of our methodology is hybrid procedural semantics. So in order to explain this, I will first explain what is procedural semantics. This is a way to represent meaning such that it is at the same time a representation of the meaning of an utterance, but also an executable program. How do we do this? This meaning representation is structured as a network, and the elements in this network we call primitive operations. And the links in this network, these will determine how these primitive operations share their information. And if we execute this network, if we execute this meaning representation, because it is a program, we get the answer to the question. Importantly, the layout of this network is determined by the question. So how does this fit together with fluid construction grammar? We analyze the question, and fluid construction grammar gives a representation of its meaning, and this is exactly this network structure. This is a network of primitive operations that we can then execute. So now you may wonder, what makes it hybrid? Well, in order to execute this meaning representation, we need to implement these primitive operations. And you can implement them in any way that you want. So what we did was combine subsymbolic primitive operations that do pattern recognition on unstructured data. So basically what this means is we have primitive operations that behind the scenes call neural networks that operate over the images. And we combine these with symbolic primitive operations that do higher level reasoning on structured data. So what does this mean? We have primitive operations that can do set operations, logical operations, search with heuristics, unification, all kinds of symbolic operations. And they operate over structured data, and this will be the conversation memory that I will introduce in the following slides. But with our hybrid approach, we have the best of both worlds. We know that these subsymbolic operations are really good at pattern recognition. We know that these symbolic operations are really good at reasoning. And with this approach, we can combine them in a very flexible way in this network, depending on the linguistic analysis of the question. So the third component is the conversation memory. And in this task of visual dialogue, every turn in the dialogue conveys new information. New information about the scene or about the image becomes present after every turn in the dialogue. And we use a conversation memory to keep track of what has been said in the dialogue. And we store this as structured information in a human readable format, so that after every turn, you can see what the agent has understood, you can see what it knows about the scene, what information it uses for reasoning, and so on. And our symbolic primitives that are part of the meaning representation, these can access the conversation memory in order to use this information to answer a question, and they can dynamically expand the conversation memory, so that if new information becomes available, it is also incorporated in the conversation memory. So here I provide an overview of the system with all three components that I have discussed. So on the left side, we start with the question. This is analyzed using fluid construction grammar, where we get a meaning representation, but a procedural semantics representation, so an executable program. And then we use a hybrid execution mechanism to execute this network in order to get the answer. And our hybrid execution method consists of primitive operations. Some are symbolic and access the conversation memory. Others are subsymbolic and they use neural modules to access the images and attentions and so on. So before I give you a demonstration of the system, I have here a summary. So at the start, we formulated the main challenge of conversational agents as combining or the combination of these unstructured and new observations with structured knowledge. In the visual dialogue task, we tackle this by introducing a conversation memory that explicitly captures and dynamically expands this knowledge. In this case, the knowledge is the dialogue history. And we introduce the concept of hybrid procedural semantics that can combine in a very flexible way the strengths of both symbolic techniques and subsymbolic techniques. And finally, something that we also think is very important is that the entire reasoning process in our conversational agent is transparent and human interpretable. So at every step, you can inspect what the agent knows, you can look into its brain, and you can see what decisions were made on the basis of what data. So to finish off, I will show you a demonstration of this Wait, I will have to check. Sorry, I will quickly try to mirror the screens because otherwise. Yeah. So this is our demonstration that we made. So this was also made by Lara and Jerome, who worked as a developer at the lab. And in this demonstration, we built a chatbot-like interface that interacts with our conversational agent on this clever dialogue task. And you can find this demonstration also online on our website of the AI group within the AI lab, so you can try it out yourself, well, later. So at the start, you have to choose an image that you want to talk about. So let's say I pick here this second image. And every dialogue in this clever dialogue task, it starts with an observation. And here the observation was made, there is a purple object. Okay, we continue. And then on the left side, as indicated, you can look inside the brain of the conversational agent. And it consists of 3 parts. So at the top, you have the observation. There is a purple object. And then in the middle, there is the execution network that is shown. But let me quickly switch this. So this, what you see now, is the result of computational construction grammar or fluid construction grammar. It has analyzed this observation. There is a purple object, and mapped this onto a meaning representation in the form of a network of primitive operations. And this network is what you see here. So these are the primitive operations that the agent needs to execute in order to compute the answer or the topic of this observation. And if we switch back here, then we can see all the intermediate outputs that were computed by the agent. So you see, it starts with the image, then we analyze the image to get the objects. We filter the objects for purple objects, because this is stated in the observation. We check if there is a unique object, and we check if there are any objects left, if the set of objects exists. So you see, we use a combination of symbolic and sub-symbolic operations. So here, this exists is just a set operation, is the set not empty, but even our subsymbolic operations, they are completely transparent because we use attention-based neural networks all the way. So at every step, you can see what's going on. And then at the bottom, we have the conversation memory. So this will store the information of the dialogue in a structured and human interpretable way. And what you see here after this first observation, that it knows, okay, there is an object, we call it here object 5, and we know about this object that it is purple. But at the moment, this is everything that we know. So I will just show you one more example so you can see how the conversation memory expands. Because after the observation, you can ask a number of questions in this task. So let's pick this first question. What is its shape? So this is a co-reference that we need to solve. And again, it consists of the same steps. We start with the question. With computational construction grammar or with FCG, we analyze this question and map it onto a meaning representation that is shown here. And then we use our hybrid execution of this meaning representation, that you can see here. So here we get the image, but also with a symbolic operation, we get the conversation memory that was built up in the previous turn, and we get the last topic from this conversation memory. Why? Because we have here this co-reference it. So we need to find what this it is about. And it is the topic of the last turn. So we find it here, and then we combine this image with the symbolic information to find the last topic in the context. This is shown here, it's this purple cube, and again, we check if it's unique and we query the shape. And in the end, with this answer computed, we can expand our conversation memory. So now we still have only information about a single object, but we know now that it's purple and it's a cube. And like this, you can go on and on, but in the interest of time, I will end it here. So thank you very much for your attention.
Okay, thank you, Jens. Maybe a quick question from my side. So you illustrate this particular application which deals with visuals of objects, but can you comment on what sort of knowledge you need to program in there, or how do you enter the knowledge that we're talking about cubes, spheres, and so on and so forth? Yeah. Or put it differently, if we move to another application where we're discussing animals and who's chasing who, what do you need to change, or what kind of sort of programming or information do you have to enter into the system, and how do you do that?
Yeah. So there are several pieces of information that you do need, of course. So first is the linguistic analysis. You need a grammar to transform these questions into these semantic or meaning representations. In this project, this grammar is engineered by Lara, but currently we also have several projects running where you have where you can automatically learn large coverage grammars from annotated data, or you can learn grammars from interactions with the environment, like a situated agent or a robot that interacts with the environment and with other robots, and this way learns a grammar like this. Then you need to design the primitive operations themselves and the concepts that can be used in them. In our group, we also investigate a lot how these concepts can be learned from interactions with the world. And these primitive operations, these are usually defined on beforehand and typically domain specific, so they can optimize. We can optimize them for the particular domain in which we want to use them.
Okay, thank you. Is there any final question maybe from the audience? If not, you will also have the opportunity, I think, to talk to both of the speakers during lunch, which is due about now, I guess, or not? One more session, okay. Okay. Then we'll cut here and let you move on to the next session. Okay, thank you. Thanks for attending. Bye-bye.